Hello everyone, I welcome you all again in this video series in which we are discussing about the machining processes. And yeah, in this we are discussing about the machining processes. And in the last video we have discussed about the tool wear and the tool life. And basically in the last lecture we have discussed about that. And that lecture basically included two videos. So in the last video we discussed about the different types of the numerical problems that has been asked previously in the gate or administrative service IAS examinations. So in this video we are going to discuss about some of the miscellaneous topic. They are miscellaneous because they have a concept, but and also they are very small. Okay, so that's why I added these topics in this miscellaneous part. So first topic that we are going to discuss about the specific energy consumption, or this is not a similar topic that I just returned the obliques because of whatever the formula that we are getting or whatever the unit that we are getting through that formula. That is same for both, like whether it can be a specific cutting pressure or it will be a specific energy consumption, but the concept is different. Okay, both concepts are different. Second, that we are going to discuss about the surface roughness, or we can say that is a peak to valley height. Okay, so there is a conversion formula is there, so we can convert, we'll find out the value of peak to valley height, then we'll convert this to the surface roughness. Okay, and this if we'll get the time, then we'll also discuss about the economics of the metal, because we have two numerical problems in this video over in this concept. Okay, so let's start. So first is the specific energy consumption and the specific cutting pressure. Okay, so for this space, for this concept, I'm using this very simple figure that we have used a lot of times previously. Okay, okay. So just assume that this is a workpiece. Okay, and here we are using a single point cutting tool. Okay, this is a tool, and the chip is coming out in this direction. Okay, so specific energy is basically specific energy we are representing with the small u because it's a specific, and that is defined by the total energy consumptions. Okay, so total energy consumption is given like I can use one more formula, that is sorry, in other terms I can say that total energy consumption will be given as fc into V. Okay, so this total energy will be as per the formula, which is distributed in two parts. First is the friction energy, and another is in the form of the shearing action, the energy which is required for the shearing action. Okay, so when it is converted into the friction, we define it by F into Vc. Okay, and when it will use for the shearing action, we define by the Fs into Vs. So for the shearing action, we are using the shear force into the shear velocity. Okay, when it goes to the frictional energy, this is the friction force, that is F, and Vc is basically the chip velocity, because this friction is occur in between the chip and the tool over this surface, or the interface we can say, of the chip and the tool. So whatever the velocity that is moving in this direction, Vc, that is basically generate friction force that will be in this direction. So that is the energy. Okay, and total energy, that is the main cutting force, because the whatever the cutting force that we are holding to the tool in this direction, that is fc, and with whatever the velocity, that is cutting velocity, that we are holding with respect to this tool. Okay, or with this tool is moving with that velocity. So this is basically the total energy. So this fc into v. So what the meaning of specific energy consumption is? Total energy with respect to that how much amount of the volume per unit time is removed, okay, in a single pass, if we are talking about. So if we are assuming that this is the uncut chip thickness initially we are taking. Okay, so this is small t. Okay, and the width we are taking, that is b. Okay, and whatever the length is there, so this is basically the L, we can say. Okay, so total volume, if initially our tool, single point cutting tool, was here, okay, and we are assuming that whatever the width of this workpiece, okay, that will be removed in a single pass only. Means ऐसा नहीं है कि like this, like if this is the width and we are holding like this and first we are removing this one and then we'll go for this one and like this. No, जो भी आपका single point cutting tool है, like we are assuming this is only the width and we are holding this tool like this, and in the single pass this material is removed, okay, whatever width is there. So the volume, like if we are keeping the single point cutting tool over here in the beginning, okay, so it will move in this direction. When it will move in this direction, it will completely cover this material, or this material is removed up to this one. Okay, so we can say that we are removing this material of L length, okay, and width is B, and the uncut chip thickness, that is T. Okay, so what volume that has been released, whatever the volume is there up to this one, okay, okay, means this much amount of the volume is released. So velocity we are representing by capital V, so here volume we can represent by this, this is L into B into T. Now here it's not a volume. We don't want the volume. We want the rate. Means in the total time, that is capital T time, how much amount of the volume is released. So that is basically I'm representing with the V dot. Okay. So this is L into B into T by capital T. Here capital T is the time. Okay. Now capital T, like total length upon how much time is taken to remove L amount of the material. Okay, so what is this? Basically, it will be the velocity. Okay, so if this will be the velocity, then this is velocity is maintained in horizontal direction, which is the direction of this apse, and that will be the direction of this V only, that is cutting speed. So this L by T, you can define this by the V into B into small t. So this is basically the V dot, so the volume per unit time. Okay, so what is the specific energy consumption? So this will be equals to total energy that is consumed per unit volume. Okay, per unit time, per unit volume with respect to time. So this will be the V into B into T. So this V both are the cutting velocities. So this will be cancelled out, and this formula will become Fc upon B into T. Okay, so this will be the cutting energy, specific energy consumption. Now, actually, this B and T. Now, this B and T is basically the terminology that we use for the orthogonal cutting. Okay, so when we are defining when we are taking defining this relationship for the turning operation, that time we have already defined in the previous videos that this B is converted into this depth of cut, and this T is converted into the feet. Okay, so when you will convert that formula, so this will come like B equals to D upon sine lambda, where lambda is basically the approach angle, and T will be equals to F into sine lambda. Okay, so this D is basically the depth of cut, which is converted through, means B is converted into D, so D is the depth of cut, and T, that is uncut chip thickness, is converted into the feet. Okay, so now here when you will put this values, this will be like Fc upon F into D. Okay, so this will be for the turning operation, and this will be for the orthogonal cutting. Okay, now if you will see the formula, then like from here, okay, this is a power. Okay, and this is power is generally that is Fc into V also, so this will be calculated in watt. Okay, and this is basically the not volume, it's a volume per unit time. So this will be in why we are assuming that that will be in mm cube per minute or per second, we can consider, no issue. Okay, जो होगा उसको जब फॉर्मूला आएगा, then जब न्यूमेरिकल होगा, that we can manipulate accordingly, so there won't be any issue. Now this watt, watt क्या होता है आपका, that is joule per second. Okay, so that will be again mm cube per second, so this will be cancel out. Now this joule is what, that is basically the work done or the energy consumption. Okay, now so this will be equals to newton into meter, so this will become mm cube. Now when you will convert this meter into mm, so this will be 10 raised to power 3 into newton into mm upon mm cube. Okay, so this will be cancelled out, this will become a square, so this 10 raised to 3 into newton per mm square. Now this Newton per mm square is basically the megapascal. Okay, or through this 10 to the power 6 you can convert into this pascal, or if you will write this pascal, sorry, megapascal will be 10 to the power 6, or if you will write this pascal, this will be Newton per meter square. Now what is this Newton per meter square or pascal or megapascal? It will be the unit of the pressure. Okay, so that's why basically initially we started this formula for this specific energy consumption, that is watt per unit volume per time. But at the end, when you will see this relationship through these units, through this unit, this formula will become a Newton per meter square. So that is defining the cutting pressure. Okay, specific cutting pressure. Now, what the meaning of this specific cutting pressure over here is, like if this is basically the cross sectional area, that is B into D that we are using, and obviously that is if it is a turning, that is F into D. Okay, if it is a orthogonal cutting, that is B into D. So how much amount of the cutting force is applied on this cross sectional area? Okay, so if basically we are moving our single point cutting tool in this direction and holding like this, okay, when you will move in this direction, this will be the FC, that is cutting force, and how much amount of this cutting force is applied over this cross sectional area, that is basically the pressure. Okay, so this you can say that this U will be equals to the specific cutting pressure, and that will be equals to FC upon B into T. Okay, so this will be for the orthogonal cutting, and for this F, this will become F into D for the turning operation. Okay, so this FC, that is the main cutting force that is applied per unit cross sectional area. So the cross sectional area will be like B into D for the orthogonal, F into D for the turning operation. Okay, so this is all in this section, specific energy consumption and specific cutting pressure from my side. Let's move to the next point, next topic, that is peak to valley height. Okay, so for better understanding of this peak to valley height, I'm using this figure. Okay, so initially we are choosing that this is the capital D diameter and small d dash is basically the diameter that is after converted. Now this is a random position at which the tool is come in contact with this workpiece and remove the material. This much amount of the material is already removed. Okay, so initially we are choosing that this tool were here. Okay, before uh, okay, just wait, I'm briefing. Okay, so this is the initially tool was here. Now this is basically the depth of cut that we have chosen through this one. Okay, and this is basically we are keeping this feed in this direction. So the feed is basically in this turning operation is calculated in mm per revolution. Okay, so what is the meaning of that is, like if I'm saying that we have 1 mm per revolution, that is basically the feed. It means that one revolution, in one revolution 1 mm will be covered. Okay, now what is revolution means, here when we are talking about the turning, then this revolution or this rotation is provided to the workpiece. Okay, and this mm, that is basically the movement of this tool in this direction. So now initially we are keeping this tool over here, not it, initially it was here, but at random position we are taking this one, and we are assuming that when one revolution is completed is we are moving our tool in this direction. So when the one revolution is completed, the tool will move, tool will reach to this position. Okay, so we can say that this is basically the this is nothing but this is the feed only. Okay, because this is amount of the mm of the material is removed in one revolution. Okay, now if this amount of the material is removed, then from the tool point of view or from the tool perspective, we are assuming that this is the peak, this is the initially this is the peak, this is valley, this is peak again. Now again when it will come to this position, this will be the valley, this will be the peak. This will happen like this. Okay, so the peak to valley height is this one. This height basically we have to measure. Okay, like sometimes we can say that it will be equal to the depth of cut, but is depth of cut is related with the workpiece, that is not related with the tool. Okay, so that's why we have to make some differentiation there, that this basically this tool this peak to valley height from the perspective of the tool. Okay, so here we are defining it by the small h. Now we are assuming some of the points, that is a, this is b, and this is c. Okay, so I'm just bringing this triangle outside. So when you will see this triangle, it will looks like this. Yeah, sometimes it happen that okay, no issue. This is a, this is b, and this is c. Now this is basically the peak to valley height. Sometimes it happens that like if I'm giving this one as a d. Sometimes it happens that when we are smoothly moving with this direction, then both the value, this AD will be equals to BD. Okay, and sometime it may not be equal. So we are just assuming that both are not equal, and this total value AB will be equals to F. This value CD, that will be equals to h. Now we are talking about this angle. So first this angle is basically the lambda. Okay, so lambda is nothing but that is 90 minus cs. So if this is 90 minus cs, then this angle will be cs. Okay, so if this will be cs, wait. Okay, so if this will be the CS, then we can say that this angle, which through this, because this is the whatever the edge, that is side cutting edge, this will be the side cutting edge, and from this perpendicular, this angle from this perpendicular, this angle is CS. So this angle will be CS, and this angle will be 90 minus CS. Okay, and this is the end cutting edge. So from the horizontal, this angle will be CE. Okay, that is the end cutting edge angle. So this angle will be CE, and this angle will be 90 minus CS. Okay, 90 degree minus CS. So now in this triangle, first we are taking this one, that is ADC. Okay, in this triangle AD, we have to find out the relationship between AD and CD. So this is, if this is the angle, then this will be 10 CE will be equals to perpendicular, that is H, upon base, that is AD. So we can get the value of AD from here. So this will be H upon 10 CE, that is side cutting edge angle. Okay, so this we can also write this one as a cot CE. Okay, so from this another triangle, that is BDC. So this will be BDC. From this triangle, this is the angle, and this is the, we have to find out the relationship between BD and CD. So this will be like 10 90 minus CS. So this will become cot. Okay, so this will be cot CS, but we are not finding out this value, we are taking this angle. Okay, 90 minus CS. So again this will be perpendicular upon base, so this will be H upon BD. Okay, so from this BD will be equals to H upon cot CS, and we can also write like this, that is H into 10 CS. Okay, so now this total value AB will be equals to that is AD plus BD. Okay, and what is the AD? AB will be equals to F. So this will be the free, that is mm per revolution, that will be equals to AD. So AD is what? H into cot CE, and BD is what? H into 10 CS. So in both the formula, both the values, H is constant. So I'm taking this side. So this will be cot CE plus 10 CS. Okay, so from this we can get the value of H. So this H will be equals to F upon I'm taking this 10 term first, so this will be 10 CS plus quote CE. Okay, so this is basically the peak to valley height. Now, in case if the surface roughness is asked, then surface roughness value that will be equals to RA. Okay, that is a standard that is defined by RA, and that will be equals to H by 4. So whatever the peak to valley height is there, quarter of that. Okay, so 1 by 4. So RA will be equals to F upon 4 10 CS plus quote CE. Okay, so this will be the relationship. This will be the relationship for the means formula for the surface roughness. Now we are going to discuss some of the two of the problems in this part. Okay, so first is first question that has been asked in GATE 2005. Okay, so the two tools P and Q have the signature. Now the signature both are in ASA form. Okay, both are in ASA. So if we talk about the ASA, then in the ASA, this will be the alpha B, alpha S, gamma E, gamma S, CE, CS, and R. That is nose radius. Okay. So what is this? First for the P, this is 5 degree. This is 5. This is 6. This is 6. This is 8, and this is 30, and this is 0. Means nose radius nahi hai usme. And for this Q, this will be equals to 5, 5, 7, 7, 8, 15, and this is 0. Now, please don't be confused. All these angles here are in degree, and this nose radius will be in inch or mm. Okay, so don't be confused. They are two tools. Okay, so they are basically used to turn components under the same machining conditions. Now, what the meaning of this line is, if whatever the parameters, which is if it is given to you, whatever the parameters that is required for the formula, if it is given to you, then it's okay. Otherwise, try to assume that that will be same, means constant. Okay, so same under the same conditions. If HP and HQ denotes the peak to valley heights of the surfaces produced by the tool P and Q respectively, means जो P के through जो surface peak to valley height है, that will be HP, and through this Q that will be equals to HQ. Okay, so we have to find out the ratio of HP by HQ. So HP अगर मैं लिखता हूँ, so this अगर H लिखता हूँ simply, then that will be equals to F upon 10 CS. Okay, plus quote, sorry, okay, H will be equals to F upon, that is 10 CS plus quote C. Okay, so now F अगर आपको feed given नहीं है, it means that whatever the value that is not given to you, we have to assume that that will be constant. Okay, now when you will take the relationship, when you will find out the relationship, that is HP by HQ, so this will be F will be here, and this terminology for this P will be in the denominator side. Okay, now when you will take this HQ, so this F will be here and this terminology will be here. Okay, so what I am writing is, this is for this P I am writing on the bottom side. Okay, and for the Q I am writing on the top side, means in the numerator this is Q, on the denominator it will be P. So this HP by HQ will be equals to, now this, as I write in the last time, this is alpha B, this is alpha S, this is gamma E, this is gamma S, this is CE, this is CS, and this is R. Alpha B, that is the bake rake angle, side rake angle, clearance angle, end clearance angle, side clearance angle, and cutting edge angle and side cutting edge angle. Okay, now what we want the value of is CE and CS. For this P, this value will be equals to 8 and 15 degree, and for this Q, this value will be equals to what? Sorry, this is 30 degree. Sorry, this is 8 and 30 degree, and for this will be 8 and 15 degree. Okay, so for this Q, we have to write first. So this will be equals to 10 CS, that is 15 degree, plus code CE, that is 8 degree. Okay, and for this P, that is 10 30 degree plus code 8 degree. Okay, so the option will be B. Okay, so let's move to the next one, and this is the wonderful problem. A cylindrical bar with 200 diameter is being turned with a tool having geometry, that is this one. Okay, So again, the coordinator system is in ASA. So okay, let's, this is alpha B, alpha S, this is gamma E, gamma S, this is CE, CS and R. Sorry. Okay, so for there are two tools basically. So for the first, this will be 0, 9, 7, 8, 15, 30, and this is 0.05. Okay, and for the second tool, this relationship is 0, 9, 7, 8, 15. This is 0, and this is 0.05. Okay, now let's start reading this question. 200 diameter is being turned with the tool having the geometry this one, resulting in a cutting force that is fc1. Okay, it means जब हम first tool use करते हैं, that time whatever the cutting force that we are getting, that value of that is fc1. Okay, if the tool geometry is changed, तो इसको हम second मान लेते हैं, this will be the second tool. So when the tool is shifted to the second part, and all other parameters remains unchanged, the cutting force changes to fc2. Means first condition में जो cutting force था, that was fc1. Okay, this was fc1. Now the cutting force is changed and that will become fc2. And also mention that all the other parameters remains unchanged. मतलब इसके अलावा जो दूसरे parameters हैं, that are same. Okay, that is unchanged. Now, the specific cutting energy, that is in joule per mm cube, that is given to you, that is UC will be equals to U naught into T1 raised to minus 0.40. Okay, where UC तो आपका joule per meter cube, that mm cube, that is cutting energy हो गया, specific cutting energy. U naught is the specific energy coefficient, ठीक है, coefficient है, means constant है. T1 is the uncut chip thickness in mm. Okay, and the value of percentage change in cutting force that we have to find out. So cutting change in cutting force क्या होता है? That is fc2 minus fc1 upon fc1 into 100. Okay, so that will be the percentage change. Now what we have to find out, देखिए हमें find out ये करना है, but relationship हमें क्या given है? That is of specific energy, specific cutting energy. कैसे find out करेंगे? ठीक है, देखिए इसमें फाइंड आउट करने के लिए, दैट्स व्हाई आई फर्स्ट वी डिस्कस द स्पेसिफिक कटिंग एनर्जी ओनली. ओके, देखिए स्पेसिफिक कटिंग एनर्जी का जब आपने हमने फॉर्मूला डिराइव किया, मींस एक्चुअल मीनिंग ऑफ दैट वाज डिफरेंट, बट व्हेन वी डिराइव द फॉर्मूला, दैट टाइम वी सॉ दैट दैट इज बेसिकली द एफसी अपॉन बी इनटू टी. ओके, नाउ टर्निंग की बात हो रही है, टर्निंग की बात हो रही है, तो b इंटू टी ना लिख के हम लोग लिखते हैं f इंटू डी. ओके, तो देखिए अब यहाँ पे क्या है कि जो स्पेसिफिक एनर्जी है, दैट इज UC एंड दैट इज गिवन एज U नॉट इंटू T1 रेज टू माइनस 0.40. दैट विल बी इक्वल्स टू, क्योंकि देखिए स्पेसिफिक कटिंग एनर्जी की वैल्यू क्या होती है, दैट इज FC अपॉन क्रॉस सेक्शनल एरिया. सो दिस विल बी FC अपॉन क्रॉस सेक्शनल एरिया, सो दिस विल बी F इंटू डी. ओके, नाउ टोटल एनर्जी, टोटल स्पेसिफिक कटिंग एनर्जी जो है आपकी, दैट इज दिस वन. ओके, ये तो सिर्फ आपका एक क्या है, टर्मिनोलॉजी है ना, दैट इज यूसी, बट यूसी विल बी इक्वल्स टू दिस वैल्यू एज वेल एंड दिस वैल्यू एज वेल. सो वी कैन से that from this formula, from this relationship, we can get the value of fc, that is the cutting force. So when you will get the value of this one, this will become U naught into F into D into T1 raised to minus 0.40. Now U naught is basically the coefficient, specific energy coefficient, so that is constant. F is the feed, D is the depth of cut, and T1 is basically the uncut chip thickness. But again, what's the meaning of uncut chip thickness? Uncut chip thickness we considered when we talks about the orthogonal cutting, but here we are talking about the turning operation. Okay, here we are talking about the turning operation. So this we have to convert it into the either feed or depth of cut. Okay, so किसमें convert हो सकता है? That is in the feed. Okay, that we have already seen this relationship, that T1, because uncut chip thickness, that will be equals to F into sine lambda. Okay, so F is basically the feed and lambda is basically the approach angle. Okay, so when you will write this one, this FC will be equals to U naught into F into D into F into sine lambda raised to minus 0.40. Okay, so देखिए अब देखिए एफ सी इज डिपेंडिंग ऑन द वैल्यू दैट इज यू नोट दैट इज कांस्टेंट। एफ आपको फीड जो है वो गिवन नहीं है, बट इट इज मेंशन दैट ऑल द अदर पैरामीटर्स रिमेन्स अनचेंज्ड। ठीक है, इसका मतलब एफ जो है दैट इज फीड दैट इज कांस्टेंट। डी डेप्थ ऑफ कट नॉट गिवन, इट मींस इट इज अ कांस्टेंट। F is again a feed that is constant. Lambda is basically the approach angle, and approach angle is if not given then it is also constant. But what is lambda? Sorry, lambda is basically the approach angle. Okay, so what is lambda? Lambda is basically the 90 minus cs. 90 minus cs, 90 minus cs means this lambda will be equals to 90 minus cs. So the value of cs is different in both the cases. For the first tool it will be 30 degree, and for the second tool it will be 10 degrees. So when you will take this one, lambda 1 lambda 2 will be different, and that will be 60 degree and 90 degree respectively. But apart from this cs, when you talk about, then alpha b, alpha s, gamma e, gamma s, ce and r all are constant except this cs value. Okay, अगर cs भी आपका constant होता then जो fc की value होगी, जो percentage change हम calculate करते हैं, that will be 100%. Okay, but from this equation this fc is completely dependent on the value of lambda only. Okay, so let's proceed for this question. So this will be equals to fc will be directly proportional to sine lambda raised to minus 0.40. बाकी सारी चीजों को एलिमिनेट कर दिया, बिकॉज नाउ वी आर गोइंग टू फाइंड आउट द रिलेशनशिप। ओके, मींस रेशियो, सो दैट विल अगेन कैंसल आउट। सो एफ सी हमें फाइंड आउट क्या करना है, दैट इज एफ सी टू माइनस एफ सी वन अपॉन एफ सी वन इंटू 100. So we can write this one like fc2 minus fc1 minus 1 into 100. Okay, so this will be like this will be a sine lambda 2 upon sine lambda 1. We can write like this, raised to minus 0.40 minus 1 into 100. Okay, now for this lambda 1, this will be equals to 90 minus cs1. So for this, that is 90 minus 30, so this will be 60 degree. And for this lambda 2, this will be 90 minus cs2, so this cs2 will be equals to 0 degree, so that will become 90 degree. Okay, so this is we have to put this value. So first lambda 2, when you will put this 90 degree, sine 90 is what, 1. Okay, and this will be sine 60. Okay, and this will be equals to minus 0.40 minus 1 into 100. So when you will calculate it, I have already calculated, and what value that I am getting is that is minus 5.59 percentage. Okay, but again in this only up to round off up to one decimal is asked, so we can manipulate it like minus 5.6 percentage. Okay, so this is basically the changes, percentage change occurs in this uh, whatever that we have to find out in the forces. Okay, by changing this cs value. Okay, so in this video we are stopping up to here. In the next video we'll discuss about the economics and some of the numerical problems. Okay, so thank you so much guys.